Okay, so before you start an experiment, you'll need to prime your pipette. And what that means is it pretty much just means to clean it. You'll stick the pipette into water, and you'll use the pipette bulb to suck the water up into the pipette, and you'll rinse it out, and you'll do that 3 times. Followed by that, you'll take your pipette and stick it into the sample substance that you have, and you'll suck that up 3 times and rinse it out. The purpose of this is to clean the pipette with the water before you get it, so that way any substance that was used in it beforehand is now gone. And then the reason why you use the sample substance is so all the residue left over in it, like this, will be the sample substance and not the water that you rinsed out. Also, it's important to know the definition of a meniscus before you start that. And a meniscus is just when the sample that's in the pipette slopes down like this. The reason that occurs is because the surface tension pushes down on the sample when it's in the tube. And how to read that is you just take the measurements from the bottom of the meniscus. So we'll start our experiment now. Okay. You can see that that's about 6.8.
7.2.
Or 7.2. So when you do that, you just write down the sample that you have. So you just write down 7.2 milliliters, and then you'll just come over here and you'll empty it out. And it doesn't matter how much you empty out, just enough to take the volume. And you got about 8.20. And what you do next is you just take the final volume that you had minus by the initial volume that you have, and then you get the volume left over, which is 1. So
I guess it's 7.2.
give one more decimal point.
What?
Give one more decimal place.
Oh, so yeah, 7.20. There.
Yeah. Okay. For this experiment, we're going to take the mass of your watch glass first. And to do that, all you do is you close the window and you tear the balance, and that just resets it to 0 and makes sure all the uncertainty is out. You open it up, you put your watch glass in, and you close it. And then you'll have to video this. And you take whatever this sits on. So we're going to use 6.89 of the initial mass, 66.89 grams. Okay, and the uncertainty in this one is the 6.895. The 100th is the uncertainty because it fluctuates and there's not really a way to tell what that is, so you'll just use the 10th. And one reason the uncertainty happens is the air can flow through it, but that's when we shut the glass to stop that. So the others is just from scale to scale, it's going to differ. So what you do now is you take the substance that you're measuring and you pour in an amount, and then you tear the balance again. And once that happens, you put it in and take the measurement of that. So now you have 113.191 grams. So to find the total mass, all you do is you take the 113.191 grams minus the 66.895 grams. That leaves you with 46.296 grams. So 46.296 grams is how much the water weighs that we put in. And also, it's important to use the same balance before and after you measure. Like for both watch glasses, you need to use the same balance because the internal calibration can be off on one. So that's why it's important to use consistency with which balance you use. And that's it. Certainty for this one is 6, and so that leaves you with 46.29 with